I'd like to start by thanking Elliot for that very generous introduction and thanking all of you for being here. It's a pleasure and an honor for me to be following Governor Dukakis and reminds me of days when civil discourse was actually still civil, when before politics was a full contact sport. Hopefully we'll be able to get back to those days. I'm here to talk about something else, though, which is financial technology. As a member of MIT's Computer Science and Artificial Intelligence Lab, I have to say that I feel like a kid in the world's biggest candy factory because we're working on all sorts of technologies that are really at the center of applications of artificial intelligence to the financial community. And so I'm going to talk about just one aspect of that. We've got many different aspects going on at CSAIL, but one of them is going to be focused on investor behavior. And for those of you who are in the financial sector, and I think there are a few of you in the audience that are involved, you know that the potential for AI to revolutionize finance is already here, and a number of applications have begun really changing the way people engage with the financial community. And I'm going to give you one example of that, which is what I call precision indexes. You've all heard about precision medicine, the idea that we can actually target specific therapies for each individual based upon his or her genetic makeup. We can do the same thing in finance now. We can think about alternatives to the Dow Jones 30, the FTSE 100, or the S&P 500 by using various aspects of financial technology to customize these indexes so we can actually have the Nathaniel Gates 30, the Elliott Wyman 100, or the Michael Dukakis 500. And imagine if we had a portfolio that took into account income, expenses, age, health, taxes, and behavior of each individual, one at a time. And now, imagine that such portfolios were completely automated. Well, this idea is not new. In fact, a number of years ago, there was an article published titled Personal Indexes, and let me read to you what the concluding paragraph of this article said. Artificial intelligence and active management are not at odds with indexation, but instead imply a more sophisticated set of indexes and portfolio management policies for the typical investor, something each of us can look forward to, perhaps within the next decade. Who was this incredibly prescient sage who wrote these words? Well, it was yours truly, but I wrote that in 2001. So you might argue that I'm a little late, given that a decade later, we still don't have full automation of our portfolio decisions. We've made a lot of progress. We've developed a number of different tools and products that allow investors to automate some degree of their financial decision-making, but we're not there yet. And so the question remains, what's missing? Why aren't we there yet? And the answer is not for lack of artificial intelligence. We have plenty of AI. What's missing is something that one of my graduate students pointed out. He said, what we need is actually artificial stupidity. We need a model of how humans make mistakes when they make these financial decisions. Now, I think that stupidity is a bit of a strong word because obviously all of us engage in certain kinds of behaviors that are quite adaptive, but they're not necessarily adapted to financial decision making. So I prefer to call it artificial humanity. We don't yet have the algorithms that capture investor behavior from the point of view of actual realized decisions. And so until we're able to capture the complexity of human emotion, fear and greed in financial markets, we're not going to be able to develop the kind of automated products that we're all looking forward to. Now, we've got a lot of theories of economic behavior. In fact, the theory that we use most often, what we teach to graduate students in economics all the time, are theories that were developed in the 1940s by Paul Samuelson at MIT and von Neumann and Morgenstern, economists and mathematicians at Princeton. And in 1947, they came up with a very succinct description of how economic agents behave. Now, being from MIT, every PowerPoint deck that I have has to have at least one equation. So here's my one equation. According to von Neumann and Morgenstern and Samuelson, we maximize expected utility subject to a budget constraint. And as a result, this theory has really taken over all of the economics literature, including the financial economics literature. And at some point, this theory of economic behavior has become so pervasive that it's really now become an economic theory of all behavior. The problem is that it actually doesn't work. When you look at how people really behave, and I've done this with a number of co-authors, including Craig McKinley from the Wharton School many years ago, we documented all sorts of departures from the standard theory of expected utility, this notion of maximizing your utility subject to a budget constraint. Psychologists have also documented all sorts of behaviors, and when you go down the description of behavioral biases, you'd be convinced, as I was, that the human animal is the stupidest creature on earth, because we all engage in these kinds of behavioral biases. Now, it took a computer scientist / economist by the name of Herbert Simon in the 1950s to come up with an alternative, which at the time was not particularly well received. But over the course of decades, we now understand that his ideas actually have great relevance to the current challenges we're facing today. And in 1956, Simon came up with this notion of satisficing. That word does not exist in the English language until Simon introduced it, and he created the word to indicate the kind of behavior that's not optimal, but it's satisfactory, it's good enough. He argued that people don't optimize because, in general, they can't. It's hard. But they come up with heuristics, rules of thumb that are good enough. And he applied this to the computerized analysis of chess, to many other contexts, and demonstrated that using these kinds of heuristics, we can actually come up with decisions that are really pretty good. An example that he gave is the kind of decision-making that we all engage in, but we're not particularly good at unless we adapt over a period of time. And one example that I've used in a number of cases is a problem that all of us face every day, getting dressed in the morning. Now, that's actually quite a challenge if you think about it. And in order to tell you what kind of a challenge I face every day, I have to tell you a little bit more about my wardrobe. So here's my wardrobe. I've got 5 jackets, 10 pairs of pants, 20 ties, 10 shirts, 10 pairs of socks, 4 pairs of shoes, and 5 belts. Now, you might think that that's a rather limited wardrobe, but I'll have you know that that gives me 2 million unique outfits, not all of which are of equal fashion content, I agree. So if that's the problem that I'm facing, I've got to come up with the right outfit for the occasion. Suppose it takes me 1 second to evaluate the fashion content of a given outfit. How long would it take for me to optimize my portfolio of outfits? Well, the answer is if it's 1 second across these 2 million outfits, it would take me 23.1 days to get dressed. And I promise you, I get dressed a lot more quickly than that. The answer, according to Simon, of how we humans are able to solve these incredible challenges is we don't optimize. We come up with rules of thumb that are good enough. And it turns out that that particular approach has been played out time and again in current artificial intelligence applications to various human decisions. So let me give you an example, and this example really tells us something about the relationship between human and artificial intelligence. So I'll do this by way of a very simple example of a piece of AI that all of us encounter all the time. A while ago, I got interested in the biotech industry, so I decided to order a book on Genentech, one of the most successful biotech companies in the history of the industry. And so I went on Amazon, searched for the book, pressed add to my shopping cart, and as soon as I did that, Amazon does this incredibly nasty, annoying, obnoxious thing. What they do is they show me 5 other books that people who bought my book also bought, and sure enough, I had to have at least 2 of those 5. I ended up buying 3 books instead of 1. This piece of AI is almost trivial from the algorithmic perspective. And it is in sharp contrast to the kind of AI that was done in the 1970s and 80s. And I know because I was there at the time. In those days, what we called AI was expert systems. You remember? Some of you who are old enough to be back in that day when you engaged in an exhaustive analysis of a particular human decision-making context. You enumerated all the possible choices, and you came up with the optimal choice. It was incredibly complex algorithmically, not a whole lot of use of data, because back then, Data storage was very expensive, unlike today. And so the expert systems of the 1970s and 80s, the AI of the early days, is completely different from AI today. Where we are today is extraordinarily simple algorithms. Let's search over all the data of people who are just like you and the choices they made in this context, and we're going to just feed that back to you. It's exactly the opposite of AI in the 1970s because the algorithms are actually pretty simple. What's complex is the data. That's where the value is. And it turns out that this kind of artificial intelligence is much closer to human intelligence than the expert systems of the 70s and 80s. And I'm going to give you an example of that. I'm going to give you an example of a certain kind of intelligence that is ingrained in all of us, which is threat identification. That's something that really we're born with, and that's come through millions of years of human evolution across different species. We are all hardwired to identify really quickly threats to our existence. So I'll give you an example. I'm going to use your visual cortex, and I want you to look at a picture that I'm going to show you and tell me very quickly if this picture is friend or foe. Is this threatening to you or not? You ready? Friend or foe? You don't know because you can't really see much, right? There's not enough data here. The actual correct biological reaction is foe. If you don't know what's going to hurt you or not, you should immediately be worried about that. But there's not enough data. Okay, so you're all quite rational about that. Give you more information. Friend or foe? Foe. Friend, can't really tell, but again, not enough data. So now let me give you more data. I'm going to give you a higher resolution photo. Friend or foe? So this is a picture of yours truly being stalked by a ninja. But actually, upon closer inspection, it's not a real ninja. It's a statue of a ninja. This was taken at the Washington, D.C. Spy Museum. With enough data, we can discern whether or not there's a threat. And clearly here, there's not a threat. Well, we do this all the time instinctively in much more complex settings. So let me give you an example of an even more complex setting. Imagine you're at a cocktail party, and you're interacting with various different attendees, learning about their backgrounds, and figuring out whether they are friend or foe over the course of an evening's discussions. And so you might find out during the course of the evening what their gender is, what their sexual orientation is, marital status, race, ethnicity, age group, and so on and so forth. And each of these particular characteristics has a certain number of finite possibilities. And so over the course of the evening, you will figure out where these individuals lie in the various different databases of people that you have met. So I'm going to give you an example of two people that you might come across during this evening's discussions, Jose and Susan. I'm going to tell you a little bit about them based upon these characteristics, and then I'm going to ask you to make 3 decisions about these two individuals, okay? We'll see how good you are doing this. So Jose happens to be a gay Latino male, single, young professional from California, no religious affiliation whatsoever, a Democrat, middle class with an MBA. Right? That's Jose. Susan, on the other hand, is a heterosexual, married female, white, middle-aged, from Texas, Christian, Republican, affluent, with a bachelor's. So now let me tell you a little bit about the 3 contexts and ask you to make a decision. The first context is that you're doing a startup, a technology startup, and you need to hire somebody to help you with that startup. Who would you rather hire, Jose or Susan? How many people would hire Jose? Okay. How about Susan? Yeah, most of you seem to want to hire Jose, okay? Second context, you're in the process of organizing a fundraiser to raise money for breast cancer research, and you need somebody to help you with the organization. Who would you hire to help you organize that fundraiser, Jose or Susan? How many people would hire Jose? Okay, how about Susan? All right. Third context, you're working at the Internal Revenue Service, auditing people's tax returns, looking for cheaters. And you have to decide whether to audit Jose or Susan. You can't do both of them because there's only so many hours in a day. Who would you audit to see who's cheating on his or her tax returns, Jose or Susan? How many people would audit Jose? Now, how about Susan? How many people would audit Susan? Wow. Wow, that's really amazing. I can't believe how judgmental you people are. Now, it's true that I asked you, but you didn't hesitate to answer. You're making decisions about hiring and firing and auditing people. It's absolutely human nature. It is part of our cognitive faculties that we are able to make split-second decisions based upon next to no information. I mean, you haven't met these people, and you're making these kinds of substantial decisions pretty quickly without any hesitation. How do we do that? It's amazing, isn't it? Well, actually, there's a large amount of data in what you just did. The data that we're talking about is the characteristics, the feature vector, if you will, of the individuals that you've met. If you go down the list at the different possibilities of gender, sexual orientation, marital status, home state, all of the different possibilities, it turns out that when you do the combinatorics, there are over 1 billion different unique personality types based upon these characteristics. 1 billion. That's more resolution than in a 600 by 800 photograph. There's a lot of information here. But here's the problem. The problem is, unlike Amazon, which actually has big data, most of us have actually very sparse data when it comes to people. How many people here have met more than a billion people in their lifetimes? I didn't think so. Occasionally, I'll have some marketing people who raise their hands. The fact is that most of us have empty cells for the given personality types that are enumerated by these characteristics. We have very sparse data, not big data, but very small data. And by the way, that's one of the problems with fake news. It doesn't take much for me to change 1 or 2 of the cells in your very sparse data set. And if I can flip a 0 to a 1 or a 1 to a 0 in your data set, I can change your behavior dramatically. Humans engage in these kinds of big data decisions long before we had machine learning. But the problem is that in many cases, we're dealing with very small amounts of data. And so unless we're aware of these kinds of biases, we can be led into making some pretty bad decisions. So the kind of things that we're doing now at FinTech at CSAIL is to try to come up with better ways of making decisions by developing better data. And 3 examples that we're working on, I'll tell you about one of the 3. The first is the psychophysiological measurements of professional decision makers in finance, namely traders. Second, applying machine learning models to large-scale household data for asset allocation and investment decisions. And finally, using survey data among institutional investors to get a sense of what their temperature is with regard to financial prospects in the economy. So let me tell you a little bit about the psychophysiology experiment, because that's something that I'm really excited about, and we're about to launch another wave of analysis. The basic idea behind psychophysiology is that we can measure the emotional state of individuals by using various different sensors applied to the human body. This is very old technology. It's based upon the kind of research that was done years ago in understanding how it is that physiological characteristics can lead to certain kinds of decisions. Lie detector tests, other kinds of measures were developed according to these kinds of instrumentation. So a number of years ago, we applied these techniques to professional Wall Street traders, and we documented certain kinds of association between their emotional state as measured by the conductivity of their skin. It turns out that when you get nervous, you start to perspire, and the perspiration can be measured as increased electrical conductivity on your skin. So skin conductance response is a key aspect of it, and we found that when looking at professional traders, they had a very specific telltale pattern. And the telltale pattern is this. You measure all of their various different physiological characteristics over time. You correlate that with their financial data. And what we found in this plot is something that's characteristic of professional traders. The blue line here is their skin conductance. And when it's high, when there's an emotional reaction, you see that value go up. And when the emotional reactions subside, it goes down. The red X's on this graph are trades that are consummated by this particular trader. And you notice a really interesting pattern among professional traders, which is that during periods where they're not doing any trades, their emotional reactivity goes down. But when they engage in a trade, then the emotional responses get back up. It's a very clear correlation between the two. When you apply these methods to amateur traders, it's all over the map. Their emotional reactivity stays high irrespective of whether they're trading or not trading. And so in these measures, we found that skin conductance of a very specific type explains good financial decision making in this relatively narrow context of professional trading, as well as certain psychological characteristics like the ability to move on. In other words, not to carry the kind of losses or gains that you may have made yesterday. Every day is a new day. And by the way, we also found some interesting gender regularities. Male traders traded more often, more aggressively, not necessarily more successfully. Female traders actually had higher risk-adjusted returns. So if you have a financial advisor, you might want to talk about that and just get a sense of whether or not you're the aggressive type or the thoughtful type in finance. It makes a difference in terms of your profit and loss. But today, so this is rather old technology. Today, what's possible, thanks to new technology, is that we can now measure traders as well as ordinary individuals using smartwatches. And we're now in the process of launching an entirely new set of analyses with professional traders with these new wristbands. And the hope is that we'll be able to tell even more accurately the kind of decision-making characteristics that lead to good financial outcomes. By the way, volunteers are needed, so if any of you are engaged in these professional decision-making contexts, we're happy to work with you as well. So let me conclude by pointing out that in the financial sector, business as usual has already been disrupted. Just like in other sectors, we already have autonomous vehicles, digital currencies, fully connected social media that enable us to interact at a moment's notice. And so it's not too far off where artificial humanity will be a possibility for us, real robo-advisors and precision indexes. You all remember the day when we had VCRs with those blinking 12s that nobody knew how to get rid of. You had to read a manual to figure that out. And of course, today, we've got all sorts of technology that has really eliminated the challenges because the technology is so advanced, it actually takes into account human behavior. Really sophisticated AI will operate at our level. It will not require us to operate at the machine's level. And this goes back to something that Marvin Minsky, the father of artificial intelligence, said at one point when asked what his goals were in his career. You know what he said? He said, I don't want to build a computer that I can be proud of. I want to build a computer that can be proud of me. And that's what we should all be striving for. Thank you.